Okay, so now let's have a look at example 1. It says work out d2y dx squared given y equals that. So this notation is saying because the power is 2, so we need to work out the second derivative of the function y with respect to x. So first we've got our function, which is y equals x to the 4 plus 2x cubed minus 4x squared plus 5. So in order to work out the second derivative, we need to first work out the first derivative. So first derivative dy dx, so basic polynomial coefficient, power down, x to the new power, which is taking away 1 because we're differentiating. So power down, x to the new power, so 4 minus 1 is 3, plus coefficient times power down times x to the new power, so take away 1, so that becomes x squared minus coefficient times power down. X squared becomes x because 2 minus 1 is 1, and lastly the coefficient disappears. So let's make that nice and pretty. So dy dx is 4x cubed, 2 times 3 is 6x squared minus 8x. So then in order to work out your second derivative, so d squared y with respect to x squared, then we just differentiate our answer we just got, which is 4x cubed plus 6x squared minus 8. We just differentiate this function once more with respect to x. So coefficient times power down, x to the new power, so 3 minus 1 is 2, plus coefficient times power down, x minus 8. And then making it nice and pretty. So our second derivative is 12x squared plus 12x minus 8. Example 2, it says if my function is f of x equals this guy, work out, double dash means second derivative at when x is equal to the value of 9, okay? So let's write down our function. F of x is 4 square root of x to the 5, 3x squared. If you want to differentiate this, since there's x's top and bottom, you could use the product rule. Or if I decide to simplify my my function now, I can use index notation and make life easier when differentiating. So rewriting square roots as powers, so that's 5 on 2 over 3 times x squared. If I'm dividing, then I just subtract the powers, so 5 on 2 minus 2. So that gives us our function can be rewritten as 2.5 minus 2 is just a half. So I could simplify my fraction so that I could easily differentiate. I mean, there's nothing wrong with using product rule. It's just a little bit longer, takes a bit more work. So let's first work out a first derivative. So because it's a simple polynomial, now that we've simplified the function, coefficient times power down, x to the new power, so half minus 1 is negative a half, making it nice and pretty. So 4/3 times half is 2/3 x to the negative a half. We want f dash dash, so we need the second derivative. So what that means is take your first derivative answer at the bottom of the page there and just differentiate this function once more to get your second derivative. So coefficient 2/3 times power down negative a half, x to the new power, so minus 1/2 minus 1 gives me negative 1.5, which is negative 3/2. Let's make this nice and pretty again. So that gives us negative 1/3, x to the negative 3 on 2 is our second derivative function, but we want the second derivative when x is 9, so f dash dash 9, so wherever x occurs you just replace it over 9, negative 1/3 times 9 to the negative 3 on 2. I mean, you can either use a calculator or use a brain, figure it out. So the over 2 means square root of 9 to the negative 3. So square root of 9 is 3. So that's -1 first. So negative means 1 over 3 cubed. So that's -1 over 3 to the 4. 3 squared is 9. 9 times 9 is 81. So that gives us -1 over 81. So to work out second derivatives, differentiate once and then differentiate that answer once